Voltage signal will be captured via voltage divider circuit. In the video, you can see the main electrical cable to which a wire for voltage signal is attached. Via voltage divider, the signal is wired to the first channel of the oscilloscope. Electrical current signal will be captured with a current clamp, which is clamped around the main power cable. The current signal is connected to the second channel of the oscilloscope. On the machine, machining regime 14 is set, with a discharge current of approximately 12 amperes, ignition voltage of 280 volts, and default settings for servo system denoted by value 6 for average gap voltage and value 10 for sensitivity of servo system. In the case of too large gap, only open circuit discharges occur. This results in average voltage of 85 volts. Average current is zero, since the gap is too large to allow a spark to occur. On the oscilloscope, the yellow signal shows only open circuit discharges, and purple colored current signal equals to zero. When we freeze the signal, we come to the same conclusions. We switch on the servo motor and start machining. During erosion cycle, we measure the average current to be 6 amperes and average voltage of 40 volts. On the oscilloscope, we notice normal or working discharges. There are many working and open circuit discharges. Few consecutive time snaps denote average current and voltage signals in the gap. On captured time snap, we notice that the first discharge is working discharge, where a relatively short delay time is present. Next discharge is open circuit discharge, to which zero current signal corresponds. Third discharge in line has longer delay time, and fourth discharge has very long delay time. If we count the squares that define time scale, we can see that a discharge lasts for 2 squares and 1/4. Time scale of 1 square is 100 microseconds. We estimate the discharge duration to 225 microseconds, which corresponds well to the setup regime. The same discharge duration can be derived from the current signal. Duration of the pause denote these short lines and lasts for about 1/2 of a square. thus 50 microseconds. This value also corresponds well with the set regime. We increase the reference voltage setting to 10. It can be noticed that the average current at erosion is lower than in previous experiment and amounts to 4 amperes. Average voltage in the gap increased to 55 volts. On the oscilloscope, we notice many open circuit discharges and relatively few working discharges. On capture time snap, we see that first discharge is open circuit discharge, likewise the discharges 2 and 3, fourth discharge is working, and fifth discharge is also working with long delayed time. We conclude that the increase of the gap led to higher percentage of open circuit discharges and lower percentage of working discharges. We lower the setting for reference voltage in the gap to the value 4. From the command panel, the readout for average current in the gap is 7 amperes and average voltage around 30 volts. High amount of working discharges can be observed, which is also evident from consecutive time snaps. In this time snap, we notice that all discharges are working discharges, with relatively short delay times. In the lower part of the screen, one can observe corresponding current signals.